So today is the first real work day for the project, and the idea is that because we have talked about series circuits last week, that you should be able to build one. So if you had signed up to do the series circuit, you should be able to get started with that, or at least start sketching out the schematics so that you can do that. And of course, if you're not building a series circuit yourself because you signed up for something else, then you can work on room design or whatever, making furniture or wallpaper or something. Okay, hopefully you have some materials for that. But today you're working on building your house. If you guys all brought your materials and you're trying to build it out of shoe boxes, cool. Start putting them together, taping or gluing or however you plan to do that. You can start decorations on your assigned room. Remember, part of your grade, the individual portion of your grade specifically, is based on what you do with that room, because your room is your grade. So everybody should have picked a room in a house that you could design, and so you can start working on that. You can sketch out your series schematic. Again, guys, I just need a couple minutes, so please lower your voices. You can sketch out that series schematic and start building that circuit. Again, check the rubric. Check the project information sheet. It tells you what needs to be in the rooms. Make sure you know what those things are, because those are the things you can be working on today. Okay, you have 3 days, counting today, for constructing your house and circuits. Your room only affects your grade. You need 2 pieces of furniture, flooring, and wallpaper of some kind, or you can just draw on paper and make it your own, I don't care, and put it on the wall to get full credit. When you actually build your circuits, guys, again, all this is in there, but listen up. When you actually build your circuits, you will need 1 series circuit that lights 2 rooms and 1 parallel circuit that lights 2 rooms. Again, you're not building the parallel circuit yet unless you want to, but you're going to have to kind of look ahead to do that. We haven't talked about it yet. Okay, so that's why I said that if you're doing series, you can absolutely get started and should, but otherwise, if you're doing parallel or combo, you can wait. This is what it's going to look like when you are actually building it. So basically, this would be the back side of your cardboard or shoebox or whatever. And then on the front, this is what you would see. This is an example of a series circuit. You can see that I have a 9-volt battery that is attached to the foil. The foil is taped so that it creates that closed loop, and it does tell you need light switches, and I recommend paper clips. You can see there's a paper clip there because what you see on the other side is this part, and you can literally just turn it. And as soon as you turn and rotate that paper clip, it no longer touches the foil and the light turns off. Okay, now if you want to go get some fancier switch or use some other material, it's fine with me, but that's what you need to have there. So you have to have a switch. You can use a paper clip for that to turn your lights on and off, and you need to make sure that you can power both of those bulbs in your series circuit with 1 9-volt battery. One thing I would recommend is to actually insulate the entire foil pathway with like masking tape, like the manila kind of tape that's not clear. If you use clear tape, you can't always tell if you've covered it all because it's clear. The other tape is easier to see. Okay, I don't have any pieces of foil exposed, which is always good because you don't want to accidentally have it contact some other part of a different circuit. Okay, but that would be my recommendation. Again, when you attach your light bulbs, they do have to go attached across a gap like this, because if you just have a solid piece of foil and you touch the bulb to it, guess what? The bulb's not going to go, or the charges aren't going to flow through your light bulb. We haven't talked about this particular concept yet, but we will when we talk about parallel circuits. Your charges will follow the path of least resistance if you give them an option. Okay, series circuit didn't have an option, so we didn't talk about it yet. But if you give them the option of going across without going through the bulb versus going through the bulb, they're going to pick going across without going through the bulb, because the bulb has more resistance than just foil. Okay, so because it has a tiny little wire inside. We talked about things that increase resistance. So if you want the charges to flow through the bulb, you have to make that happen by only giving it one path. That path has to go through the bulb, which means your foil should have a break in it like you see right here. Okay, you do have to have exposed wire on both sides of your Christmas light. I'll give you some of these in a minute for those of you that are ready, but they're already stripped and there are pieces of copper that you can see on either side that you will contact to your wiring or foil in order to do exactly what you see here. You would have to poke a hole through the cardboard to the front for the bulb to poke through, and then of course your wiring is on the back. For the paper clip, same idea. There has to be a gap because you have to be able to turn it on and off. If you look at the diagram here, you can see when it's on, the charges would be able to flow through the paper clip because it's a conductor, it's metal, they'd be able to go across the gap. When you turn the switch off, you're opening a gap, and so there's no longer a path for charges. So that's how those work. You can see how it can make your light turn off, of course, if you rotate it that way, but this one's still on. This would be a parallel circuit, which we haven't talked about yet. Again, when you attach your battery, same idea. It needs to be across a gap in the foil. Guys, if you include a short little piece of foil in between it, it's going to take that. That's the path of least resistance, and that means you are short-circuiting your battery. If you recall from the FET, the battery catches on fire. Now, real world, it probably won't catch on fire, but it will get really, really hot. And I suppose if you had paper near it, you could potentially start a fire. So let's not do that. Okay, let's not short circuit our batteries. Leave a gap in your foil so that your battery can connect to either side. One terminal will connect to one side of the gap, the other terminal to the other side of your gap. Do not connect it directly. Don't just like stick the battery on the foil. Don't do it. Okay, that's how you get a hot battery, and that's how you don't light your lights. All right. Again, guys, you selected your jobs in the group planning sheet. Check that sheet for your tasks and go ahead and start getting to work. We haven't learned parallel or combo yet, so if that's what you're supposed to be building, work on your room right now. Draw a schematic. If you want to know if it's going to work or not, check the FET. All right, guys, go ahead and get to work. If you have questions for me, please let me know.